programming. And it's kind of very general, but it's good enough for us at this level. We talk about the primitive data types. We call it also built-in types. They're both pretty much equivalent to the labels that they give it. Primitive is because actually it's what the compiler started with. And then we have assignments, statements that utilize the built-in types. So this is the most basic. This is the built-in, the foundation. Then we have a library called math. And within this building block that is at the bottom, the foundation, we also talk about the string library. Now, this is where we are. We didn't do the text IO, although we did it with arguments. Today, I would like to get to scanner and standard in, which that will give you more options, or I would like to say better options also, because you can prompt the user for what you want instead of hoping that it will enter the arguments based on the knowledge already of what the arguments belong, or where the arguments belong to. And this is where we are right now. And now, I did tell you many times that learning programming doesn't have a linear trend. It kind of goes in circles. And so we are going to be moving things around a little bit. And even though these are the blocks that you see over here, one on top of the other one, we can start doing some other things without arrays. The same thing with functions. But if you wanted to see in terms of complexity, then you can say that arrays at a lower level than whatever we do over here in terms of, this is another layer of complexity or abstraction, whichever you want to call it. And then we make it even more abstract by hiding some of these things by creating functions and modules. And then that should be the second part of the year in which we do this objects-oriented programming. Let's scroll back down. We did all this, we blah, 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 blah. We answer questions. We learned about the while loop. We learned about this. I think people answered this question. Did you guys answer this question? Did we answer this question? Yeah.
Yeah, we did on Monday.
So the answer to this is, and it should be part of your lessons. Who can tell me? I forgot the curly brace. Well, yes. Correct. Yes. So let's do some of the stuff that we're going to do today. It's part of what you're going to put in the lesson notes. Oh, what is that? What you learn from this question over here is that without a curly brace, this, or a set of curly braces, only one line of instruction will be counted in the while loop. Actually, I don't want to keep on typing in the, oh. I'm gonna make this bigger in the while loop. And so if you don't believe it, you can test it. If you don't believe me, you can test it. And you can write a small program and see what happens. If you, that is right. Very good. Ian said that, um, so I will always be zero. It will ignore these two lines over here, and it will keep on going forever. This is the infinite loop, right? Excellent. Um, let's keep on going over here. I think we already had something started last time, right? I don't know if I did or not, but I'm going to put notes on conditionals. Oh, yeah. There we go. Short, and let's move on. I ask you to read ahead. I am the only thing I'm going to say about this is that if you are a student who has been already involved a little bit with calculus, this should look very familiar. So for those who do not know what this is, it's okay. What I really want you to know is about implementing the square root. This is a function. SQRT is the square root function that the math library has. So here is actually how they actually you could say that is using this type of idea to find the square root of a number. That some of you who took calculus or taking calculus, maybe you were exposed to that. I know I did that at one point somewhere, but I don't remember exactly at what level. So what is interesting about this? Is there anything that we want to know from here? Yes, here's another example of how to use the absolute value. What is this? How do we write that? Is that real code? Let's take a look. I'm going to first put this in my text file because when I put it in my text file, it cleans it up for me. Takes some of the stuff that should not be there. And let's take a look at BlueJ. There you go. Let's run it. I want to know what that E is. What's the name of it? SQRT? That's an ugly name. New class, put whatever gibberish you want. Let me bring it over here. We should have created a different project there, but we're gonna do it. So SQRT, I'm gonna put my initials over here, only because I don't like functions names to be used as part of a program. Nothing's gonna happen, but it's ugly. Compile without any errors. Take a look over here. What is that? Who can tell me what that is?
Scientific notation.
Scientific notation, did you say?
Yeah.
Yes. So if I wasn't going to write it differently, it would be what? 10 to the what?
-15.
Yes, correct. Very nice. Thank you. Huh? I don't know what it's doing there. I'll take a look in a minute. Hold on. The first thing I want to do is auto layout because boy, it's ugly. This file is huge. I mean, the size of it in my computer is missing my tiny real estate. Because after I mirror this with Zoom, it takes half of the screen off. I don't need this over here. I'm gonna put it down here. Let's see, Ethan has a good question. Oh, is because it's looking, that's a very good question. This has something to do with floating points. How high of the precision do you want? So the difference between the number that you want calculating, right? And they use the absolute value, by the way. And then C is the one that you enter, the one that you're trying to figure out. So this equation right here, you're using to see how close we are to the actual number that we're trying to calculate. Since floating point numbers could change tremendously in terms of the trailing digits, the decimal digits, we have to have that concept of limit in the neighborhood. So how close do you want those two numbers to be to? And in this case, we made it very tiny. We made a very small number. Maybe if you're looking at money, just 2 decimals will do. But if you're looking for a high precision, then we need to compare it. This is like epsilon, if anybody learned epsilon in calculus, and it's always within the neighborhood. How close are you to that number? We're actually gonna spend one period talking about comparing floating point numbers. So that will be the answer. The smaller the error tolerance is, Ian, is the higher the precision in your calculation. That's what that means.
Okay, so what that means, that's now like the program will find the absolute value of like t minus t plus like.
Yes. If we were going to do operations with money, dollars and cents, obviously the error will be much bigger than this. We will get just about a penny. I don't know, sometimes it may be even 10 cents. It depends on the application. Okay, let's keep on going. I'm gonna skip this because I don't think everybody's interested in that. But remember, if you are a person who is interested in computer science and math, these are things that you should feel very related to. Not everybody feels that way. And so I kind of skip it, but I let everybody know that it's there. The next loop we're gonna learn is the for loop. And I am going to take this and I'm gonna put it in my notes. But I had to find my notes. And this is in my way. What are my notes? Hey, look who's there. Where did my notes go? I didn't close them, right? Or maybe I did? Yes, I did. What? Oh, no, I did not. All right, so let's go down here. And we're gonna call this the for loop. Pay attention that it's in lowercase. So what does it say? Is this an alternative to the repetition structure, right? Like in the while loop, right? Let's go back up quickly. The while loop ran as long as this condition was true. But sometimes you know exactly how many times you want to run the body of the loop. And that's when the for loop is very convenient. So in this case, we actually have 3 parts to the header of that for loop. This is where you actually initialize the counter. This is what it's going to be counting how many times the body of the loop is going to be running. This is the condition that will make sure that you finish at that point. So let's say if I is 0 and n is 5, then this is going to run how many times? Very good, 6 times. 0, 1, 2, 3, 4, 5. That makes it 6 times. And then here we have the increment. Now these 3 parts of the for loop are separated with semicolon, not with commas, semicolons. And then we need the curly braces again, because if we don't put the curly braces, it's only going to take the first line of code after the for loop. So to make sure that it takes everything that we want in the body of the for loop, we actually use curly braces. And so here, the same as we did with the while, we can do it for the power of 2. We can do it also with the for loop. We can tell already what n should be like equal to, and this is going to be repeated exactly the same. And it will stop when n is equal to 5, let's say, if we chose 5 to be n. Here's the while loop, right here, right next to each other. As you can see, it's kind of putting a comparison between the 2 parts. So for many cases, you might want to use the for loop because you know exactly how many times you're going to run it. For other cases, you won't be able to do that because you might be looking for a particular outcome within the body of the loop that will set the condition to false and complete the repetition. You can also have the end I outside the for loop and just say I equals to 0 here. We do that, and actually we should put that. Let's bring this. I don't know if I can bring this over here. Let's see what happens if we bring it to the nodes. And I'm going to ask you to turn this in, so make sure you take notes. In this case, the variable I will, where's the word?
So like increase by 1, yeah.
How do you spell C's?
Yeah.
Is
That's
that right?
correct.
What's that?
That's correct.
Okay. Will cease to exist once the loop is done.
So the done means like the I is equal to 5.
Yeah, that's correct. But you can, and in many cases, you're going to want to know how many times the loop ran. You can have it even after the loop is done if, well, we can say, anybody wants to tell me? What can I do? So we can have the value of I after the for loop is finished. It doesn't disappear, it doesn't go away. Well, how can I change this so I still can actually use the variable I?
Define it outside of the
Yes, you
conditional.
can say I equals to 0. And Java doesn't like you to do this, so we need to remove that. Now this over here, we can say this happens because I is a local variable. Now here we can say this way, I is not local. And it will still be there after the loop ends. So put this over here.
I just have a question.
Yes.
Is it possible to, inside of the loop, say something like, like set another variable c to be equal to the value of I. If you do that, will c keep the value of I, even if it's a local variable?
And up here,
Like in the for loop, if you add like a section where you put like integer c equals I,
yeah, you
is
can, yeah, you can put anything you want. Is this what you mean?
Oh no, I was saying like instead of using the on the top in z equals 0, if in during the for loop you set like int z equals equals I, would z be a local variable?
Oh, no, that variables don't, no, it's the primitive data types don't know that. Objects actually do that, if they have the same reference. But I and Z will be independent of each other. So the changes in I will not be reflected in the change in Z.
Right.
And I think that's the question you have.
The question, probably a better way to phrase it would be, if you define a variable in a for loop, is that a local variable or is
Yes,
that?
it's local.
Oh, okay, it's anything inside the loop.
Like for example here, right? No, V was outside.
Okay.
Let's go back over here. We can say something like this. That's a very good question because that's called the scope of a variable. So if I put over here something like this, and I say int Z equals to 54, that's the loop. So I'm gonna say the scope of Z is local. And then when I try to print, and this is pseudocode, right? Print Z, if I print C, error over here. So Z is local. It only happens over here. And that's why I pulled it, the way it was written over here, it made I also local. And so when this finish, the body finishes, when all this finish, I don't know how many times it actually run. So if I want to know that, I have to declare outside. So it's not local to the block of statements. Every time you create a variable inside of curly braces like that, that's called the block statement, then that will be our local. And we call it the scope. And that's where the actual variable is active, is alive. Did I answer your question, Philip?
Yeah, thank you.
Okay, good. All right, let's go on to the next one.
I also have a question on the for loops.
Yes.
So in Python, there's the thing where you can say like for I in range 6,
Yes.
a certain number of times. So you can't do that in Java, right? There's no like range function.
Right. Well, that would be here you will have the range. This is actually the range because the I++ is going to be adding 1 to it. Actually, let's get the program going. I believe that the best way to learn is by practicing things like this. So a new class, and we're gonna call it for practice. Actually, wait, for loop. There we go. Where are you? So I'm gonna put it over here. I'm being very casual about it. I'm gonna get rid of all this. So Python has a very comfortable way of dealing with a lot of things. Java doesn't. Okay, so let's create a for loop. And let's do it in local IJK are very common variables for counting in the loop, by the way. And then you have, so this will be the equivalent for in range, right? Because if you put a number, it will go from 0 to something, to that number that you're asking for. And let's say I is, as long as I is less than or equal to 5. The only difference is that here you have to do the increment. And in Python, range does the increment. Unless you want to change the increment and then you have another argument and you put by 2, by a negative number. And so this is where you will have that particular thing. And that will be I plus plus. I plus plus is the increment of 1 by 1. Yes.
So it's by 1.
Yes, only by 1.
So we could write it like I plus equal 1.
Yes, you can do that. Yes, you can do I plus equal 1. That's correct. And now let's do, let's just print this because I just finished doing that with the Python class. System out, print line, and let's just print I. Semicolon, compile, no errors, looking good. Let's see what this looks like. And this is pretty much in range. And in range, you will have a 5. And you will take a, actually, no, you will have a 6 because you will not take the 5, right? In Python. So if I do this over here, and there it is, 0, 1, 2, 3, 4, 5. Actually, I just did exactly the same thing with the Python class in range. So if I don't put them equal over here, then it's going to be different, right? It's going to be different. It's not going to count it. And that's what happens in the range, in range. All right. You can do a lot of things with the for loop. Also this, I think, I don't know if I ask you, but this time I'm going to ask you. Those are part of the lessons questions. Yes. So on today's question number 1 is, what can you have or not have in the header of the for loop? And I want you to answer now. I want you to find that out. I'm going to put this on the lesson questions. And save it. Put it over here. And let's keep on going. I don't need you. Go away. And here, you're going to have all this. You're going to need it. I'm going to give you assignments that are all related. They're all coming from here. For example, let's take a look at the first one. Here it says compute the sum of the numbers from 1 through n. N is included. You see that, right? N is included. This one, it does the factorial. Take a look over here, factorial. Oh, I cannot make it bigger. So sum is outside the for loop, so you can see what the end result is when the for loop is finished. If it was declared inside the for loop, then when the for loop is finished, you wouldn't have access to sum. That's why it's outside. Take a look, no curly braces, because there is only one line of code in the body of the for loop. When we talk about good programming practices, that's considered a bad practice. I'm not a hardcore for that, so I'm fine with it, but you should know the standards out there. Here, the factorial, they use long, which is an integer with more space in the computer. So when it grows, it can actually fit in there because the factorial could get big. Of course, it will. If it is too big, it's going to be an overflow, right? How do we do that? Take a look at how cool this is. the way they do this is actually cool. This is what Ian was saying before. The plus equal y equals I refers the same as saying, that's correct. I plus plus is the same as I plus equals 1. Or I equals to I plus 1. This is called the modified assignment operator. Oh, so this is question 2. All right, next. I can do the same thing for, oh, sorry. But I plus plus is the unary operator to increase I by 1. You can also have this one. I, where's my I? Minus minus. Unary operator to decrease I by 1.
Or I minus.
That's correct. So here on the modified assignment, hold on a minute. You can also have I times equals, that's not a times, equal, I don't know, 2. And so in this case will be in this case, it would be, I think everybody knows what that is, right? It would be the same as saying I equals to I times 2. There you go. All right, let's move on. If you have questions, ask me, okay? Again, the product is outside the for loop. Then here we have the pi. I like this one. What is this one doing? Let's go back to here. Anybody knows what that is doing? Who can tell me what is happening here?
Calculating.
Is doing what?
I think maybe calculating circumferences.
Ooh, cool. What number can we put there? Oh, very good, very good. Oh, it doesn't matter, I think. Okay. Highly, pretty good. Let's put a 5 here. Is there anything else? Let me lay it out nicely. I know the output is there, but I like to feel it. I want to see it. Let's use binary here. So I am not going to display this. Violet. Yeah. There you go. Isn't that exactly? Let's take a look over here. Let's go down. Actually, wait, before we do anything. So as you can see, it took one line of code, right? What happens now if I say system out print ln k? Oh, so you can see k is local, only local to the for loop right here. K is only available on this line. So if I actually wanted to print it out, then I would have to pull it out. Go. Let me get that other thing out of the way. And I think it's time to look at the scanner and other things like that. Compile it. Where are you? I need more screens. There's never enough screens. There you go. And it ran 6 times. If I wanted to be part of the for loop, then I will need the curly braces in there. It's going to look ugly, but it's going to give you, actually, I know we can actually move this around to make it kind of having some type of purpose. I'm going to get print, only print. Only print, what does it do? Only print.
It doesn't insert a slash.
Yes, very good. I'm just going to print the value. Not the value, just the letter K. Because in the original, it doesn't tell you that. There you go. Where's my terminal? Let me clean it up. And let's run it. There we go. And here it is. K is 1, and that's what you get. A whole bunch of things. So the only way I could have more than one line as part of my for loop is if you have the curly braces. And there is something that we already did, blah, 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 blah. This is an ugly thing. There's a video on that. Maybe I'll look for it. You guys want to watch it, you can do that. This is C++, so I don't know. Oh, forget, never mind. It's just, everybody gets the joke? Ha, 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 ha. What does the following program print? Oh, this is a good one. Page 22. Where's my notes? Okay, from page 22. Yeah, mamacita. Okay, I should stop too. And I'm not gonna do it now. You're gonna do it for homework. This one. What does the following program do? Which is on page, I'm gonna put this on part of the notes. Right here on the lesson questions. And then let's do a scanner. Lesson questions. So let me put that in there. Hang on.
Since we already submitted this yesterday, are we do we have like multiple attempts to like resubmit it?
Yep, I believe it's unlimited. I'll
Okay.
take a look again, but I believe it's unlimited. It's up to you, whichever you feel more comfortable. Whichever it makes it easy for you to read. In my case, I'm fine with either one. No, I don't need to go away. Okay. Let's put the other two that we have over there here. So this was the next day. Hey, what's happening here? You guys, why are you coming at the last minute?
I was waiting in there was another Zoom meeting for a second block first period, and I thought we were supposed to be in that one, so we were just waiting in there.
How did that happen?
Yeah, this is the fourth period Java Zoom. I just tried to join both of them to see which one was open, and this one was open.
Yeah, I'm in the same boat as Brendan. I thought it was the other Zoom because that's what we used usually.
I'm sorry. I'm gonna have to make that more clear. Well, that's not a question. Oh, I can make it into a question. Mhm. I gotta be careful with that. It's not the first time that I do it. Okay, so the question is, what happens if a set of curly braces is missing? Well, for those who just came in, I recorded the actual lesson, so I will post it a little bit later when it's actually, I had to trim it a few parts. That there are some faces in there that I had to get rid of. Yes. The three questions that we answered, actually, I did not answer 2 and 3. So you had to answer for homework. And let's do the scanner. Let me make sure that it's unlimited. Yeah, unlimited number of times to submit, because I knew that we were going to go back multiple times. Okay, so let's go to modules. How much time do we have? I want to do at least a scanner. 10:33, 7 minutes, we can do it. All right, so there are more ways of actually inputting data. We're gonna use first the scanner class. And here I already put together a program, but before you do that, I want you to go to, we're gonna go to this link. Let's see what's in here. It's the same thing, I think, yeah. Okay, so we don't need it right now. Get out of here. This is the one that I want you to look at. I think, I don't know, I think I mentioned this. This is what it used to be called the trail. This is more or less how I learned a lot of Java, because there are a lot of examples. It's actually pretty good. This was created by the creators of the Java compiler. Let's go back over here and let's take this program. Do not forget to include the import over here. And I'm missing something over here. I'm gonna fix it when we get to the, here we go. And so let's go back to Ruche. Okay, I didn't shrink it, I should have. I'm gonna call it anything, blah, blah. I'm gonna put it right here. And I'm going to take all of this and I'm gonna paste the new one. So it's having problems over here because I did not do the right thing over here. Come on, work with me. There. There. All right, And again, I kind of lax over here. The documentation is not that critical today in this type of helper programs. Okay, number one, you need to import it. This line always have to be there to use the scanner, of course. You need to create an object of scanner. So let's do that together. As documentation. Are you all with me? Ian, are you with me? Yeah. Okay. So we're gonna say that this line creates creating a object of the class scan. I know that you have no idea what that means for now, but eventually you will. Just keep that in mind. I'll tell you why I know that. Class of scanner. I'm going to say because of the new operator. The new operator creates objects. And the way that it creates the object is by knowing what the scanner looks like. You don't know, actually, I don't even know what it looks like. I just know that the scanner class will know how to create it when the new operator calls it. And it needs one argument, system.in. So make sure this is also something that you just have to have there. Then everything else is kind of more variable in terms of, yeah, it makes sense. So here we have, we declare a variable called name. Its data type is a string. And then we declare two more variables of double data type, base, and exponent.
So they are both numbers.
Yeah, that is correct, floating point numbers. And here's how we prompt the user finally. Oh, are convenient, but the user doesn't know what you want. Now here we prompt the user. It says, well, give me the base. And so the object of scanner is scan. So let's put that over there. Scan is the object. So we need to use the object to get all the functions, but we call them methods because they're objects. But methods and functions is pretty much the same, just in two different settings. So I call the object and I call the method or function, quotes and quotes. In this case, we want a double. So if you look at the documentation of scanner, it has to be just like this. And then just like next, like this, it takes a string. You can also call next integer, next float, all of them. You can look at it in the documentation. So you prompt the user, enter the base, enter the exponent, enter your name, and then it does the calculation using PAL, math.pal. Notice that we didn't have to import math. Math is built into the actual compiler. It's in the Java that util or language, one of those two. Let's compile it, make sure that I didn't mess it up. And now we're gonna see something good. Finally, we're gonna see prompts. Something that we didn't have with the orgs. Put, enter the base. And see, as you can see, the program is running. See at the bottom, it's waiting for input. Let's say it's a 2, 5, Grace. And there it is. Homework. Answer those questions. The questions in the lesson.
I don't see it on one.
Okay, I'll tell you in a minute. Okay, hold on. Here's you have to use the, remember when you use the, you're gonna use the scanner over here to answer, to actually write this program. This is an assignment. Where is it? It's right here. Take a look. Go to modules. There are questions in the lesson questions, and you need an assignment right here. So you have these two,